Hello students, this is third video for assignment 7.1. In the first one, we had question 1 and 2 explained. In second video, we saw how to arrive at expression for current in AC circuit with capacitor only. Now in today's video, we'll see how do we determine how much is the current passing through AC circuit with inductor, only inductor. Okay, so let us consider AC circuit with inductor only, and then we'll see how to find out current passing through such circuit. So, as inductor is also a non-ohmic component, when you connect it with any DC source, it acts simply like a wire or resistor. But when you connect it with AC source, as current value is changing, flux linked with the coil will change, and then there is self-induced EMF. And because of that, the current value is will not increase or decrease as expected by the source. And then we say that the inductor is controlling current, it is influencing current, and that factor or parameter is called reactance, inductive reactance. So in such circuit, how do I determine that if my voltage is doubled, suppose instead of 5 volt, if I make it 10 volt, how much is the effect on the current? How do I know that? So for that, we should have some expression of current. So that is what we are trying to derive. Once again, as I consider voltage to be function of sine, I would like to represent it on the V versus T graph with sinusoidal wave. Okay, how much is this value? The peak value of voltage is Vm. Okay, and we know that inductive reactance can be given as XL. So V is equal to Vm sine omega t. You can consider it to be cos omega t also. For now, I consider sine omega t. It is equation 1. And we know that inductive reactance XL is omega L. We are not using it for now. Now, how do I determine current in this circuit? So, we know that voltage across inductor can be given as L di by dt. If you go back to previous chapter, electromagnetic induction, uh, you will come to know that potential difference developed across an inductor can be given as L di by dt. So di can be given as V by L dt. Integrating both sides, we get this integration is from 0 to I on left side and 0 to capital T on the right side, or else let us not consider limits for now. Integration of di will give me I, and L being constant, I can write it outside integration Vm sine omega t dt. So Vm again is constant, so it is Vm by L integration sine omega t. What is integration of sine? It is minus cos. So it will be minus cos omega t by omega. And then the equation of current is I, which is equal to I, which is equal to minus Vm by omega L cos omega t. So if I make use of second equation, XL is equal to omega L, I can write this as I is equal to minus Vm by XL cos omega t. Again, as Vm and XL both are constant, you can replace it by single constant let it be Im cos omega t with negative sign. So this is the equation of current for AC circuit with inductor only. This is the equation of voltage. Let me write it separately here. So V is equal to Vm sin omega t, and I is Im cos omega t with negative sign. It means that current is function of sign, but it will start increasing in negative region first. So again, I have to be careful. When voltage is maximum, current should be zero. When voltage is zero, current should be maximum. So the graph should be like, it should be starting with maximum, negative maximum, and then it will arrive at its zero. When voltage is zero, current reaches maximum. When voltage is maximum, current should be zero, and so on. How much is this value? This value is Im. Okay, maximum value of current, peak value of current, which is Vm by XL, Vm by omega L. So this is the nature of graph of V versus T and I versus T. One more thing I would like you to try out by yourself. What will be the value? What will be the value of current or equation of current if I take cos omega t instead of sin omega t? If you take V to be Vm cos omega t, how this equation and equation of current in capacitive circuit with only capacitor will change, that is also one interesting study you can carry out by yourself. So try out. Take voltage equation to be V is equal to Vm cos omega t, and find out current equation for capacitive circuit and inductive circuit. Okay, so that is all for this video. We'll discuss the last equation of this assignment in next one. Thank you.